Hello, everybody. Hopefully you did pretty well on the test we just had in class. Now, what we're going to be covering after this is learning a bit more about derivatives, how they work, but I want to start by giving you some special tools which will make it easier for you to find derivatives. So the tools I'm going to be talking about today are the product rule, the chain rule, and the quotient rule. Now, we're still applying the derivative. We're not going to be dealing with much application for just this one, just because I want you to be able to see how this works. So I'm going to give a quick run through of proofs of these and give an example of using each one of them. So first, let's talk about the product rule. Well, product is a term for multiplying. So if you can take your function and you can make it the product of two separate functions. So for example, if your function is e to the x times x to the fourth, well, one function is e to the x, the other function is x squared. So those are your two functions getting multiplied together. Whenever you have this type of situation, you can use the product rule. So we're going to go with the basic definition of derivative. The limit as h goes to 0, sorry about that, of f of x plus h minus f of x all over h. Well, since f is equal to g times k, it's the same thing as g of x plus h times k of x plus h minus g of x times k of x all over h. Now, the next step, we add and subtract this middle term. Because if you have negative gx k of x plus h plus gx times k of x plus h, well, those would cancel out. So we're not actually changing our equation on the top, but we're adding some terms that will be useful for us. So if we group those together, we'll get g of x plus h minus g of x times k of x plus h, and minus g of x times k of x plus h minus k of x all over h. That looks ugly. So let's go ahead and split it up. So we can change this over into this part here. I'm sorry, that's supposed to be a plus in the middle there. Now, when we do this, we have what looks like the derivative of g, the derivative of k, but they have these extra things getting multiplied onto them, which, as long as these are continuous functions, we can split the limits up over them. So this right here, yeah, you can easily see that's the derivative of g. Derivative of k, well, there's no h's in here, so that's just g. Well, the limit as h goes to 0 of k of x plus h, well, that's just going to go to k of x. So what this ends up giving us is the formula that the derivative of a product is taking the derivative of each part separately and multiplying by the non-derivative part. All right? Now, this could end up working for 3 terms or 4 terms, whichever way you want to go with it. But basically, if you have a bunch of things multiplied together, you take derivative of one, multiply it by everything else. Take the derivative of the second term, multiply that by everything else. And just go down the line, and it'll work for any number of functions get multiplied together. All right, so that's the product rule. Chain rule. Now I'm showing the chain rule next because we need the chain rule to show the quotient rule. So chain rule basically means if you have a function inside of another function. So our example here is e to the x squared. Well, that can be viewed as e to the x and x squared. So the x squared's inside the e to the x. You can tell that by the x was replaced by x squared, therefore it's interior functions. So if ever you can find an interior function and an exterior function, usually you'll want to look inside parentheses to find them, then you'll be able to use the chain rule. So if we look at this, well, that comes out to the g of k of x plus h minus g of k of x all over h. That looks ugly. Let's add to it. So if you multiply by k of x plus h minus k of x, top and bottom, you'll get something that looks like this. On the right, well, that looks a lot like the derivative of k. On the left, well, that's not quite as nice. But if we view k of x plus h and k of x, well, we can view that as similar to x plus h and x, which means this will actually come out nicely if we're looking at the limit as these two things are going to 0 when you subtract them. Actually comes out to the derivative of g, still evaluated at our function k of x, but then multiply that by the derivative of k of x. All right? This is probably the most difficult rule to make sure you implement properly. So always double check your work for this. Now the quotient rule. This one sounds nasty, but when you combine it with the other two rules, it's pretty simple. So quotient is another way of saying division. All right? So an example here is e to the x divided by x squared. We have our numerator function, we have a denominator function. Now, this is basically just an extension of the product rule, because we can take our denominator function and raise it to the -1 exponent. Oh, and now it's in our numerator. Therefore, we can then use our product rule on that, which when we replace that back in, which at this point, we're using the chain rule. So we take the derivative of the outside function, so multiply by -1, subtract by 1, so that's -1, that's -2 up there of m of x, and then multiply by our derivative of our inside function, so the m prime of x. So we just used our chain rule. Now, with a little bit of simplification, it ends up looking like this. Well, that still looks pretty ugly, doesn't it? But we can go one step further, and we can see that it looks very similar to our product rule now. Derivative of our first term, then just our second. Then we subtract our first term times the derivative of the bottom. Now, you're wondering why we have to subtract from the derivative of the bottom? Because the bottom has the negative exponent on it, so it's going to cause a negative. Some of you might be wondering where this mx came from. Well, I just got a common denominator of mx squared. So that is our basic quotient rule. And here it is, again spelled out with just g's, k's. Feel free to pause for a moment and write these down. These will be on test sheets from now on. I won't really be providing them for quizzes or anything like that. But make sure you should know these within the next couple of weeks. You should have them down perfectly. Now let's look at a few exercises quickly. So exercise 1, let's find the derivative of this function. Well, you should easily be able to tell what rule we're going to use. So go ahead and pause it. Try and run through. All right, hopefully you've tried it. Well, our two functions should be pretty clear which ones we found. G of x is everything in the parentheses on the left. K of x is everything on the parentheses on the right. Pretty straightforward. So, do you have the derivative yet? If not, pause and then continue. All right, hopefully you have that done. So here's our derivative. We're using our basic power rule at this point, where you take your exponent down, subtract 1 from the exponent. That's it. Now, if you need to, go back to the formula and using these, figure out what your answer should be. All right. And here's the actual formula in case you decide not to go back. Now go ahead and put everything together, and you should get this lovely thing right here. It is still long, it's still ugly, but I would accept you leaving it in this form instead of trying to simplify it out. Because if you try to simplify from the beginning, you would end up with 9 different terms. And that would lead to something very ugly to deal with. All right. Second exercise. Well, you can probably guess what it's dealing with. Quotient, actually, not chain rule. Well, go ahead and try this one out. All right, hopefully you've tried it. First two parts are the same as the previous example, so the g of x and the k of x is still the same functions. So the derivatives are still the same. Now, here's the formula, so go ahead and try and put it in this form. Hopefully you've done that properly, and this is what you should be getting. Again, I am not going to force you to try and simplify this out. It is ugly. If I want simplification, I will ask for it. All right, now on to the third exercise. Now, if you look at this, you should be noticing an inside function and an outside function. Whenever you have parentheses, whatever's in there is usually going to be your inside function. And to find your outside function, replace whatever's in the parentheses with just an x, and that'll tell you your outside function. So in this case, it would be x cubed is your outside function. Now, if you take the derivative of both sides, you'll get this. So go ahead and use the chain rule formula to try and get your answer. Here's the formula in case you need it. All right, hopefully you've tried putting it together, and you should get this. Keep in mind you have to take the derivative of your outside function and put your inside function back in. And that is a mistake. All right. This should actually be the derivative of this function here. Sorry about that. I will try and get that corrected or add some annotation to it before the end. All right. See you in class.